Alright, good morning or good afternoon, and welcome to what we're calling Lesson 6 of Module 1. Today we're just going to review all of the rules we've learned so far about exponents and all the different shortcuts, and just really practice them before we get into our next part of this module on scientific notation. So let's go ahead and begin. Alright, just to begin, we're going to review each of the rules we have learned so far. So when we multiply numbers written in exponential notation that have the same base, we add the exponents. For example, if I have 5 to the second times 5 to the third, this is the same as saying 5 to the 5th power. We just add those exponents up. Okay? When we divide numbers that are written in exponential notation and have the same base, we subtract the exponents. So maybe I have 10 to the 15th divided by 10 to the second. This would be the same as 10 to the 13th power. Okay, I can also write it out without that fraction sign with an actual division sign. Okay. Next one we learned is when we raise a number that is already written in exponential notation to another power, we multiply the bases, or the exponent, sorry. So say I have 5a to the second power, and I'm raising this to the 5th power. This is the same as, first I'll break apart what's in my parentheses already. Okay, then I'm just going to distribute that 5 to everything that is inside. So 5 times 1, that'd be 5 to the 5th power. 2 times 5 would be 5 to the 10th power. So that would be that expression broken down. Okay. The next rule we learned last week was that anything raised to the 0th power equals 1. Okay, that could be a number raised to the 0th power. That could be a variable raised to the 0th power. It's just always going to equal 1. And then the rule that we learned yesterday was that to turn a negative exponent into a positive exponent, we simply flip our fraction. So if I have 1 to the negative 4th, I'm going to write this as 1 to the negative 4th over 1, and then I'm just going to flip it upside down. And when I do that, that exponent becomes positive. So this is what we've learned so far. We're going to practice all these rules today in our lesson. Make sure you have them down so that you can reference them, because, like I said many times, we do mix up these rules when we get a lot of different questions going on, especially when we have to apply more than one rule at once. We tend to just get confused and do the wrong thing. So make sure you have it down so you can reference it and check to do the right thing each time. Let's go ahead and get started. Alright, for each of these sections, we are going to go through and answer them together as a class. For the first one, 5 to the second times 5 to the 5th. We're either going to add those exponents, subtract them, or multiply them. Please message me in the chat what you think we should do. Add, subtract, or multiply. Alright, same base. What are we doing with those exponents when we're multiplying? We are adding them. And so this is the same as 5 to the 7th power. Okay? Below that, m to the 7th times m to the 3rd. What are we doing with these exponents? Are we adding them, subtracting them, or multiplying them? We are adding them. So this should be m to the 10th power. Alright, next expression is a little bit more lengthy. We are multiplying these two terms, but the first thing that we're going to do is we're going to pull this expression apart. So I have 4 times h to the 5th power times negative 7 times h to the 1st power. Okay? first thing I want to do is simplify my numbers. So here are my like terms, a 4 and a negative 7. I can go ahead and multiply those two together. 4 times negative 7 is negative 28. From there, I can multiply my exponents together, my numbers that are written in exponential notation. So I have h to the 5th times h to the, there's an invisible 1 first. And just like these two over here to the left, when we're multiplying numbers that have the same base, we add the exponents. So this is the same thing, times h to the, well, this is a 5 plus a 1, 6 power. Okay, and we can simplify our answer even more by just removing that times sign. So this would just be negative 28 h to the 6th power. So our answer here would be this one. Let me know if you have any questions. Make sure you have it all written down, especially all of that stuff right there. Write it down so that you understand how we got to that step, or that answer, that conclusion. Let's continue. All right, up on the top left, are we going to be adding, subtracting, multiplying, or dividing? Actually, we don't even divide exponents, but add, subtract, or multiply those exponents. Well, we're dividing numbers with the same base, so we would be subtracting them. So 7 take away 2 is 5. We keep our same base. This is negative 5 to the 5th power. Below that, we have two things that we're doing negative 28 into the 6th, divided by 4 into the 3rd. The first thing I want to do is pull this expression apart. So this is the same as saying negative 28 times into the 6th over 4 times into the 3rd. And so we're going to do this in two parts. First part is we're going to divide negative 28 divided by 4. Well, negative 28 divided by 4 is negative 7. The second part is we're going to do into the 6th divided by into the 3rd. We're dividing numbers that have the same base. Written in exponential notation, we just subtract our exponents. So n to the 6th divided by n to the 3rd, 6 minus 3. This is the same as n to the 3rd. And I took away the dot because I don't need it, because it's a number adjacent to a letter. There's an invisible multiplication sign, so this is the same as saying negative 7 to the n, or n to times n to the 3rd power, which is this one right here. Okay. I want you to go ahead and try the next two on your own. Take a couple minutes to do it. I'm going to give you 2 minutes exactly, and then we'll go over it. First thing I want to do is break this expression apart. I have negative 5 times z to the 2nd times 2 times z to the 9th. Going to do my like terms first. So I have a negative 5 and a 2. This is negative 10. And then I have z to the 2nd and z to the 9th. This becomes z to the 11th. So negative 10 z to the 11th is my final answer here. The one below is the same as saying 4 times h to the 5th times negative 7 times h, and there's an invisible 1 right there. I'm going to do my numbers first. 4 times negative 7 is negative 28. And then h to the 5th times h to the 1st. This is h to the 6th power. All right, let me know if you have any questions here before we move forward to the next slide. All right, this is the last slide we're going to do together before you get some time to work on this on your own. Up in the top left, we have -2. It's being done 3 times. So this is the same as saying -2 to the third power. It's really important that we keep that those parentheses. Otherwise, we're not going to get the same answer. The correct answer is this one right here. Below it says, Mike says the final product is positive. Is he correct? We have a negative number, -1.25, being multiplied by itself 15 times. This 15 is odd, which means our answer is going to be negative. So he said it was going to be positive. Is he correct? No, he's not correct. Okay. And then the one off to the side over here, I'm going to break it down. We have 3 times 10 to the 4th times 3 times 10 to the 5th. We can go ahead and multiply our 3's first. 3 times 3 is 9. And then we'll multiply our 10's that have exponents next. 10 to the 4th times 10 to the 5th is the same as saying 10 to the 9th. Okay? And we can simplify this out by just removing this dot. So this is the same as saying 9 times 10 to the 9th. But they don't remove the dot or the multiplication sign within our expression up top. So we're just going to go ahead and choose our answer based on what we just did. Okay. Moving on. All right, for these next slides, the remaining parts of this lesson, you're going to work on it on your own for about 15 minutes. And in 15 minutes, we will come back and review all of the different answers, okay? Go ahead and begin your work. All right, let's go ahead and review your answers for this one. For the first expression, we have x to the second times y to the 4th, and we're raising that whole group to the 3rd power. So you can imagine doing this whole group 3 times. How we're going to simplify this is we're going to multiply this exponent to both of these. So x to the second times 3, 2 times 3 is 6, y to the 4th times 3, 4 times 3 is 12. This was our answer. Okay. To the right, 8 to the 10th divided by 8 to the 7th. We are subtracting 10 minus 7 is 3, so this becomes 8 to the 3rd. The next one is the final product positive or negative. We look at our exponent. This is even, so it's going to be positive. All right, check your work, and let's move on to the next one. All right, moving on to this slide here. The first thing I'm going to do in the top right one is pull this expression apart. This is actually a 6 times x to the 5th times a 3 times x to the 5th times x to the 0th. All right, I'm going to highlight the parts I'm going to multiply first. I have a 6 and a 3. Those become 18. Next I have x to the 5th, x to the 5th, x to the 0th. When I multiply numbers that have the same base, I add those exponents. So 5 plus 5, 10, plus 0 is 0. So this is x to the 10th. So my final answer, 18 times x to the 10th. Down below, we're going to break this apart as well. The same as saying 3 times m to the 2nd times n to the 7th over m, and we're doing this all 5 times. Okay? One thing I want to point out is this is m to the 1st right here. So the first thing I want to do is I want to look in those parentheses and see, can I change anything? Can I simplify anything within the parentheses? And I can, because m to the 2nd divided by m to the 1st, that reduces to just be m to the 1st power. 2 minus 1 is 1. So my new expression is 3 times m to the 1st times n to the 7th times 5. And I'm going to distribute this 5 to each term. So this becomes 3 to the 5th, m to the 5th, n to the, what's 7 times 5? 35. All right? Now, there is one more thing we can do here. You'll notice none of these says 3 to the 5th. So I actually need to multiply this out. What is 3 to the 5th power? That's the same as saying 3 times 3 times 3 times 3 times 3. 3 times 3 is 9. 3 times 3 is 9. 9 times 3 is 27. 27 times 9 is 243. So 3 to the 5th power is the same as 243. So it's not going to be this one or this one. And then we have m to the 5th power. This one right here. And n to the 35th power. This one right here. So this is our answer for this question. Moving on to the next one. We have negative 2 times x to the 4th to the negative 2nd power. How can I get rid of this negative exponent? Well, this is a fraction. I can flip it upside down. So this becomes 1 over negative 2 times x to the 4th times positive 2. From there, this exponent is going to be distributed to both terms, negative 2 to the 2nd. And then x to the 4th times 2 is x to the 8th. All beneath the 1. The last thing I'm going to simplify. Negative 2 to the 2nd power. Well, if I'm doing this twice, 2 times 2 is 4. But it is a negative 2. Sorry. Was in parentheses, so we're going to keep that negative sign. So this is going to be negative 4 to the 2nd power. Or, sorry, negative 4 times x to the 8th. So it'll be 1 over negative 4 times x to the 8th. Should be this answer choice right here. On the bottom, we have 18 times c to the 2nd divided by negative 3 times c to the 3rd. I'm just going to divide my numbers first. 18 divided by negative 3 is negative 6. Then we have c to the 2nd divided by c to the 3rd, so we're just going to subtract this. This becomes c to the negative 1st. And if we want to turn this c to the negative 1st into a positive, we're just going to put it on the bottom of our fraction. So right now there's an invisible 1 underneath here. We're just going to move that c to the 2nd to the bottom. So my negative 6 stays up top. Keep the 1 on the bottom. We move our c to the 1st power to the bottom as well. And it becomes positive. From there, we can get rid of a couple of things. We don't need this 1. We don't need this 1 right here. Those both aren't doing anything. So our final answer is going to be negative 6 over c. Okay, take your work with mine, and then we will move on to the next slide. All right, should have known the number raised to the 0th power is 1. Up top, we're doing a times a to the 6th times a to the 1st times a to the 2nd times a to the 3rd. Keeping our base, we're just adding all those. 6 plus 1, 7, plus 2, 8, 9, plus 3, 10, 11, 12. And then the one below. I'm going to pull this all apart. We have 2 times a squared times b, there's an invisible 1, times 4 times a, there's an invisible 1, times b to the second. I'm going to start with my numbers. 2 times 4, this is 8. Okay, so I can already cross off this and this. Then I'm going to do my a's. We have a to the second times a to the first. 2 plus 1 is 3. A to the third. And then we have our b's. B to the first, b to the second. 1 plus 2 is 3. So 8A3, B3 is our correct answer. It is this one right here. Let me know if you have any questions before we move to the next one. To turn a negative exponent positive, you multiplying, flip it, change the negative to positive, or adding, you flip it. Okay? Down below, if we want to change all of these negative exponents to positive, all we're going to do is we're going to flip this whole thing upside down. When we do that, this 2 becomes positive, this 10 becomes positive, this y becomes positive. From there, x to the 10th divided by x to the second, that simplifies to be x to the 8th. And y to the 8th, it just stays the same. So x to the 8th, y to the 8th is our final answer here. This next one, we have a negative 4 times x to the 0th power. We should know that x to the 0th power is the same as 1. Negative 4 times 1 is the same as negative 4. Alright, make sure you have those down. Let me know if you have any questions before we move on. Alright, this is the last one here. It says, are the following expressions equal? 1.23491 to the 0th power equals 2 over x divided by 32 to the 0th power. What do you guys think? Well, the first one, this number is going to this whole number, which is just one number. So this equals 1. The second one, we have a lot more terms. It is a 2 times x over 32. We're doing all of these to the 0th power. So that means this becomes 2 to the 0th power times x to the 0th power over 32 to the 0th power. Well, 2 to the 0th power, that's actually 1. X to the 0th power, that's actually 1. 32 to the 0th power, that's actually 1. 1 times 1 is 1, over 1 is 1, and that equals 1. So, are these the same expression? Do they equal the same? Yes, they're both raised to the 0th power, so they both equal 0. Right, next one, simplify 3 to the negative third. If I want to make this positive, I'm just going to flip it underneath the fraction. Now I have 1 times 3 to the third. 3 to the third power is the same as saying 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. So 1 over 27 is our answer here. Next one, are the following expressions equal? We have 2 to the third, or 2/3 times negative 2. If I want to change this negative to a positive, I'm just going to flip this. This becomes 3 over 2 times 2. Is that the same as 3 over 2 times 2? Yes, it is. Those are the exact same. Okay, make sure you have it down. Let me know if you have any questions before we move into our closure for today. Alright, just to review our lessons, or our lesson summary, when multiplying numbers written in exponential notation that have the same base, we add the exponents. For example, x to the 4th times x to the 5th is the same as x to the 9th. We add those exponents. When dividing numbers that have the same base, we subtract. For example, x to the 4th over x to the 2nd, same as x to the 2nd. We subtract those. When we raise a number that is already written in exponential notation to another power, we multiply the bases, or the exponents. We're doing this. We're going to distribute that 3 to both terms inside. This would be 5 to the 3rd times x to the 6th. Next, anything raised to the 0th power equals 1. And lastly, to turn a negative exponent into a positive, we simply flip our fraction. So maybe it's 1 over x to the negative fourth. We would just flip this upside down and this would become x to the fourth over 1 or x to the fourth. Okay? Your exit ticket for today is 10 questions in Galileo. It's kind of like a mini quiz. Instead of an exit ticket, you have the rest of the time to work on this. There's no reflection for today. So please head over to Galileo and utilize your notes to help you out. Okay? Reference them in the different rules where you know as you solve these questions. Go ahead and get started.